Hello and welcome to this session, LO1. Understand the concept of operating systems. Today, we will explore what happens when you switch on a computer and how the operating system acts as the essential link between hardware and software. We will look at its key roles, different types, and the boot process that brings your system to life. An operating system manages your computer's hardware and software resources. It acts as a bridge between user and hardware, providing a stable environment. Core roles include resource management, hardware abstraction, user interface, and security. Without it, applications could not run smoothly. It ensures multiple programs do not conflict over resources. Operating systems provide a consistent platform for applications. They expose standard APIs, allowing apps to function across different hardware. Software portability is achieved through this consistency. Applications run seamlessly across devices thanks to the OS. This abstraction layer simplifies development and enhances compatibility. Operating systems come in various forms: desktop, mobile, and embedded. Windows, macOS, and Linux dominate desktops. Mobile OS includes iOS and Android, each with unique features. Embedded systems use specialized OS like RTOS and embedded Linux. Each type serves specific hardware and use cases. Windows is the most widely used desktop OS worldwide. It began as a graphical shell over MS-DOS in 1985. Windows NT kernel combines monolithic and microkernel elements. Its strengths include broad hardware support and a vast software ecosystem. However, it faces challenges like licensing costs and malware targeting. macOS is Unix-based, exclusive to Apple hardware. It offers excellent performance and tight integration with Apple products. The XNU kernel combines Mach microkernel and BSD elements. Its strengths include long update support and a seamless ecosystem. However, it is limited to Apple hardware and has a high cost. Linux powers most web servers, cloud platforms, and supercomputers. Created in 1991, it is open source and highly flexible. Major distributions include Ubuntu, RHEL, and Debian. Its strengths are security, stability, and broad hardware compatibility. Linux is dominant in cloud and server environments. iOS and Android are the leading mobile operating systems. iOS offers a closed ecosystem with strict app sandboxing. Android is open source, allowing third-party app installations. Both systems have unique security and interface features. They dominate the global mobile market with distinct user experiences. Embedded OS run within dedicated devices for specific functions. They face resource constraints like limited RAM and no display. RTOS guarantees precise timing, crucial in critical systems. Embedded Linux is widely used in industrial devices. Windows IoT provides familiar APIs for enterprise teams. The boot process loads the OS into RAM for execution. It begins with the power-on and post-hardware tests. Firmware then hands off to the bootloader, which loads the OS kernel. The kernel initializes system components and mounts the root file system. Finally, the init system starts services and presents the login screen. Post checks hardware functionality before OS loading. It verifies CPU, RAM, and input devices. Firmware, either BIOS or UEFI, manages boot device selection. BIOS is older, with limitations like small disk support. UEFI offers faster boots, larger disk support, and secure boot for security. The bootloader bridges firmware and OS, loading the kernel into RAM. Grub is common for Linux, while Windows uses Boot Manager. Kernel initialization sets up memory management and hardware drivers. It mounts the root file system and starts the init system. This process is crucial for system stability and performance. Operating systems vary in license, kernel type, and use case. Windows and Mac OS are closed source, while Linux and BSD are open source. Kernel types include monolithic, hybrid, and microkernel. Use cases range from personal computing to servers and embedded systems. Each OS has strengths and weaknesses based on design. To pass, explain the OS purpose and roles clearly. Cover desktop, mobile, and embedded OS types comprehensively. Describe the boot process accurately, including post and firmware stages. Quality of explanation is key to scoring well. Use diagrams and structured explanations for clarity. Engage in activities like OS selection for specific scenarios. Practice boot process sequencing and BIOS versus UEFI decisions. Compare OS options for server environments. These exercises deepen understanding of OS concepts. They prepare you for practical applications and assessments. Operating systems are vital for managing computer resources and providing user interfaces. Understanding their types, roles, and boot processes is essential. This knowledge empowers you to make informed decisions about technology use. For support or questions, reach out via WhatsApp at 0748 4361 688. We're happy to help. Thank you, and see you in the next session.